Hello everyone. In today's lecture video, we're going to be looking at the development of supplementary specifications. More specifically, we're going to be looking at the specification of non-functional requirements and also design constraints. We're going to, at the end, look at the linking of those supplementary specifications to use cases. Speaking of use cases, see, the thing is, not all of our requirements are functional requirements, as you know that. I mean, if you have a requirement saying that we have to use Windows 10, we cannot really put that in a use case. This is why we need supplementary specification. Okay, it's supplementary because it supplements the functional requirements that is already stated in use cases, and it doesn't have really a lot of room in use cases, so we gotta add this separately, be it non-functional requirements or certain design constraints. Okay, so basically, when it comes to non-functional requirements, they're always more or less the same, in the sense that there's a set of categories that you'll find those non-functional requirements fitting into. Okay, obviously there's some additional miscellaneous non-functional requirements that can happen in every project, but you can bet every time you want to go and and elicit the non-functional requirements for a project, that there's a set of categories that you're always going to come across, and it's a pretty good idea that you should be asking those questions when you get to those projects. So a lot of the times you'll see things, requirements that are specified at a high level, and we know that breaking them down into lower level requirements it could then lead to some function requirements being created. We've already seen a number of examples to this, but at the high level, before even we get to the breaking it down into more specific function requirements, we can set a certain suite of metrics. Okay, so that's the easiest way to make sure that we have achieved a non-functional requirement or not. It's just to make sure that there's a metric out there. So we don't want to be leaving soft goals as non-functional requirements. We want to set them as these are our goals. These are what are the things we look for by setting a measurement, and if we pass it, we pass it. If we don't pass it, we don't pass it, right? So one of the first and most important categories is usability. Obviously, the ease of use of a product. Usability is a big deal in the industry. It's not something to overlook as oh, this is just something that, you know, if we have time to get around to it, we'll do it, or it should be some sort of an overthought. A lot of companies owe their massive success to usability. Okay, there was a time back in the day in the 2000s, earlier 2000s, where Nokia and BlackBerry used to be the two dominant forces in the in the cellular phone, mobile phone industry. And then came along iPhone, and it swept the whole market away, iPhone and Samsung. But before that, before iPhone made its debut along with Samsung, the reason was that those two different phones, being Nokia and BlackBerry, used to hold the majority of the market, is that they weren't easy to learn. Okay, and what happens is that when somebody buys a Nokia phone, because they only have one or two options available, and they spend quite a bit of effort into going through that steep learning curve and finally being able to be proficient in using that phone, they don't feel that they want to go through this again by switching to a different brand of phone. So they just get the newer version of that phone. Okay, and it was thought to be very hard for any other phone to come in and compete in that market until iPhones did it, and Samsung. Now the way they did it is that they created phones that are so easy to use that even if you haven't had any prior experience to using cellular phones or any phones in general, it's just so obvious how to go about using those phones. obviously an amazing touchscreen as well. Wouldn't help, but nonetheless, the ability to be able to be productive with that phone is so amazing. Was so incredible. Okay, we're talking about two levels of productivity here. Okay, how much training time or how much learning curve to be minimally productive, just to accomplish the most simple task, or to even be operationally or productive. That's achieving the day-to-day tasks that we want. And I'm not talking just about phones here. I'm talking about any software system in general, right? So one of the ways to see how usable a software is you measure how much time do people take in order to perform those minimally productive tasks or just the operational tasks. Okay, for example, if I ask you to set an alarm on your phone and then I time you, how long does it take you to do that? Okay, if it takes you an hour, that's probably too long. All right. So we got to specify the required training time, okay, to become minimally productive on operational productive. And usually, those need to be within a certain level, because if you go beyond this, then chances are the software that we've created is not actually very, very usable. Okay, gonna specify measurable task time. This was I was saying a moment ago about, set the alarm and then we'll see how much time did you take. Even ask you, for example, to send a text message, and then we'll see how many typo mistakes that you do while you're writing the message. And with it, we can, adjust the keyboard layout. One thing we want to do to measure usability is to take those times that we've been doing over here and compare it to the usability of a previous system. Okay, so that could be like your benchmark. At least, I might not be amazing. There's always room for improvement, but at least the new system is better than the old system. Okay, so that I have proven that I have done some significant improvement there. Okay, usability doesn't have to be in the sense of somebody using a software only, but usability can come in the form of the availability of, say, online help, wizards, tooltips, user manuals. These are the sort of things that, them being available for the user, it makes it easier for them to understand how that software works and for them to be more proficient in using it. Okay, maybe usability can be affected by certain HCI, human machine interface. You have a course about this in third year next year, and the community of HCI, or even human to machine interfacing, they created a set of standards and conventions. Okay, there is a lot of science behind this, a lot of science that have empirical data behind it. That means there's a lot of statistics that's been crunched with regards to this matter to actually show that, certain standards, certain techniques of designing your layout, of designing the navigation of your software, and how does this have an effect in improving the usability or not improving the usability of a particular product. Okay. The next criteria we're going to look at is category, should we say, is reliability. And reliability comes in many different flavors. Okay, so the first of which is availability. Okay, so one of the most things that you consider about a piece of software being reliable is that when I want it, it's there. Okay, and one of the most common cyber attack techniques is something called a DOS attack. That's called the denial of service attack. And this is where you flood a system with a lot of bogus requests, usually created by a machine, just for the sake of keeping that server so busy that it's not available for legitimate users to use it. And this is what we call DOS attack. So this legitimate user, when they get to use that server and realize it's not available, then they're turned off by that system, and they'll say, maybe I'll switch to a competitor. So availability is obviously something that is considered to be a big deal. A couple of other metrics is the mean time between failures. Okay, so you'll say like the system should only be allowed to fail once every such and such amount of time. Okay, this could be specified in days, months, or even years. Okay, and then when it goes down, we have something called the mean time to repair. How much time is going to actually take in case it does breakdown, and again, you can say down in terms of minutes, hours, days, whatever it is that you want to put it in, and what it is you find acceptable. This is called the mean time to repair. How much time, in case something does happen, how much time is it that we're going to need to repair it, okay, on average. Another aspect of reliability is accuracy. Okay, so sometimes the actual truth is out there, but it's hard for us to create software that shows the accurate results, the real truth itself. So it's gonna show us results that it should be close to what the reality is. Okay, and this is called accuracy. For example, you have software that can scan a crowd, and it should be able to tell you how many people are in that crowd. Okay, now obviously there's the fact, there's the truth of really how many people are there, and then there is the estimate that is created by the software using its algorithm about how many people there actually are there. All right. Now, what we want to do is we want to be able to test that software so that we actually bring in some crowds of people that we know how many they are exactly, and we use that software on them. And so with it, we see the delta, okay, how accurate it is. Okay, so if it was 500 people, what did the software say? Did it say 505? Did it say 550? And with this, we can actually specify the level of tolerance to the accuracy. Okay, so it could be, we can say something like it could be 1% off, it could be 10% off, plus or minus, and so on. Okay, next up is things that are related to the testing phase. Okay, you have different criteria. Some of them could be the maximum bugs, how many bugs should I have, the defect rate, usually expressed in how many bugs per 1,000 lines of code. And then sometimes it's not just the number of the bugs. Sometimes we care about the significance of the bugs. And usually this is in industry. You'll find something like trivial, okay, or should in minor, and then intermediate, and then we got the severe. Okay, so you see different names here, but it's the same thing. And it could be that for each one of those, they actually have a set number. Okay, so for example, it'll say trivial. Yeah, sure, you can have as many as those. We don't really care. Intermediate, maybe no more than 20 per 1,000 lines of code. Severe, maybe 0. Okay, so you set those criteria, and this is usually something that is set by the quality assurance department. But then again, obviously, as a customer, when you want to write this, should be able to set down the non-functional requirements for the production. Okay. Now again, you're saying, well, this is not really related to me creating code per se. It's true. I mean, non-functional requirements and requirements that's coming in from a customer doesn't necessarily relate to the functions that we're actually creating, the code that we're actually creating. Okay, so think of something like online help, as we've mentioned before with usability. This is not something that relates to the code, but it's related to the production of software in general. All right. Next category is performance, and we have a number of metrics for that. The first of which is a response time for a transaction. So you put in something and you're waiting for time, for amount of time for the server to respond back. Okay, how much time? What is the maximum allowed? What is the average that should be allowed or deemed acceptable? Throughput, it's the number of transactions per second. So how many transactions can I crunch per second? It's not a case of being able to perform a transaction correctly, but how many can I perform per second? Capacity is very similar to throughput, but it's basically saying what is the maximum number of transactions that I can be handling anyways. Okay. And capacity can come in many different flavors. And so one of the times that I would be doing in one of the jobs that I had before, I wanted to test a piece of software, and we're looking at performance. We know it works. It's just, is it going to work properly in case 500 of these pieces of software are running at the same time, 500 clients are hitting the server at the same time. So I remember I had to go to work during a Saturday, and Saturday, that's a weekend in North America as it is over here actually. And I would log into many different computers, and in every computer I would, turn up 20 different clients, and this is kind of like to stress the system and see how many it can actually, how many transactions can it perform, what is the capacity that it can handle in total, and obviously the response time per transaction. Okay. Another category is called the flexibility. Okay. Flexibility is kind of like the ease of uh, us being able to modify our software. So in general, we consider a piece of software to be flexible in case we were able to make a lot of changes with very little effort. So that is a piece of software that was considered very flexible. At the opposite, vice versa, if I have to do a lot of effort to make very, very little change, this is considered to be a piece of software that is not very flexible, right? Other than the non-functional requirements, some of the requirements that we get actually come in the form of design constraints. Okay, so those constraints, they don't tend to affect the external behavior. They're not actually coming in and saying we want the software to do this and we want the software to do that. But usually what they do is they restrict the design space that I have, and they restrict, sorry, not the design space. The restrictions coming in from the design space restrict the requirements that I'm actually setting down itself. Okay. So in general, most requirements, it should be allowing for one or more design options. Whenever it's possible, we actually want to leave design decisions to designers rather than specify them in the requirements. We don't want to say something like you have to use an Oracle database system unless we really, really have to. All right. So we don't want to be putting these restrictions on the design phase unnecessarily, but that's not going to stop the design phase from coming back and saying, well, given the situation, given certain limitations that we have in the design world, we have to go back and set certain requirements in a certain way. Okay. Some of those design requirements could be compatibility with existing systems. Okay, so you've got to be able to run on the new and the old platform. Certain application standards coming in from from the developers library 99724, for example, and maybe a corporate best practice. Sometimes the corporate best practice that I'm talking about is not just a use of a particular language, but maybe even a coding standard. So things like even indentation. Yes, even indentation. Your code could be sent back to be revised if it's not following the proper indentation. Okay, so this has got nothing to do with what sort of functions your software is actually is going to be creating. Okay, a lot of the times you'll see design requirements, design constraints being set by the programming language of the current platform. So it happened to me when I was working in New York at the stock exchange company, and basically they said that we're not going to be accepting any work that you do that is in C# or C++, because all of the systems on all of the platform are Java based, and they invested quite heavily in Java. I remember this word is, they told me this very, very well, and they said they highly invested in Java. But actually it was in my benefit because all of my studying was in Java, so it worked out perfectly for me anyways. But nonetheless, had I been a C# developer, I would have had to been forced to switch to Java instead. Okay, some of the standards doesn't have to be coming in from the IT department of the corporation, coming in from the outside. Okay, things like regulations imposed by certain standards in the United States. Some of these standards can come in from the FDA, the Food and Drug Administration, the Federal Communication Commission, Department of Defense. There's so many, maybe even more than this list. The Federal Aviation Administration, that handles anything that's flying in the sky. Okay, so these are different organizations that says if you're going to be creating software in this domain, it has to follow these certain rules, and those certain rules can maybe put some design constraints, and those design constraints in turn you have to go back pre-traceability. Remember pre-traceability? And see what sort of requirements are affected by it, and you have to change them and set them accordingly. Maybe even create new requirements for this. Okay, so whether you update or create new requirements, you still got to be able to distinguish between those requirements that was set there because it was on the wish list of a customer, or was a requirement that was set there because of a design constraint. You got to be able to distinguish between them. Okay, you want to include all these design constraints in a special section. Identify the source for each of these constraints and why we have any of these requirements in place. Okay, so the rationale behind them. And in general, yes, we can consider design requirements as a requirements because it is it's setting a contract, a standard, a specification that needs to be satisfied, and it's imposed formally in some sort of a documentation. So we got to treat this design constraint just like any other requirements and make certain that the system design has to follow and satisfy those standards, the specification or contract that has resulted actually from a design constraint rather than coming in from the customer. Okay. Physical artifacts themselves can there could be some requirements about it. Okay, so like I said, not all requirements have to be about the code. It could be, like I said, the online training, online even or help material that is available. Okay, physical artifacts and requirements come in physical. I mean, a lot of our software is not going to run on thin air. None of our software is going to run on thin air, so it's going to run on physical system. And sometimes the customer will have some requirements related to physical artifacts, how tall it should be, how short it should be. Maybe it's dealing with other hardware machines, so it's got to conform. For example, if this is something that's going to run on a USB, well, then it's got to satisfy the physical requirements of a USB drive. Requirements related to, for example, the target system configuration and how it's prepped up. Support and any training requirements, any internationalization, localization. So internationalization is requirements to make our product global and accessible by any person in the world. Localization at the same time is catering and a specific product so that it's actually more relevant and more applicable to a particular local market as well. So this is the trick, right? Creating software that is global and at the same time it's also local. So you want to have something with many different languages. It adheres to the definitions of certain words. You know how the words, for example, football means something in England, and in the United States it means a completely different thing, the word football. They're actually two completely different sports. Okay. So yeah, localization and internationalization requirements. If, going back again, we have a use case and it's related to a particular non-functional requirement, there is usually a special requirements field at the very bottom of every use case template, and with it we can write down and link it to any specific non-functional requirement that we have in order to say that this particular requirement when it's being executed, with this use case, when it's being executed, when it's being performed, you know, it should also be sure that this execution should also adhere to certain particular non-functional requirements if they're actually applicable. Okay, and that'll be it for today. I look forward to posting up the next lecture video. I'll see you then.